Hello learners, welcome to today's session which is on clustering techniques, and this is a part of data mining and data warehousing course, and today's portion has been taken from block 4 unit 11. If you remember, in the last few sessions I've been talking about especially on data mining, and we understood what exactly the data mining is. And if you talk about the previous session, we were talking about the classification techniques. Classification techniques where we talked about this is one of the supervised way of learning, and we can do a lot of prediction and classification using this technique. And especially we talked about decision trees and how to build the decision trees, and this is what exactly we discussed in the last session. Today's session, if we talk, we are actually talking about clustering. So we will start with what exactly the cluster is, then followed by what are the general applications of clustering, and then we will try to understand the clustering techniques with the help of some clustering applications, and then we will understand what do you mean by good clustering, because there are many techniques which employ the clustering, and clustering basically talks about having a set of items in a particular group. So we will see that what exactly the good clustering means, and followed by the conclusion. So if you see, clustering basically finds a group of records which are similar in nature, right? That means all the clusters, within those clusters, all the records, all the objects, all the items are very, very similar in natures. And for example, if you want to classify or if you want to cluster the customers by 3 different features like income, age, revenue, you can see that we have a male income which is less than 12,000, age is less than 23. They are the one who is actually buying the Coke. And we have a female customers whose income is less than 12,000 and age is less than 23, but they are not the Coke buyers, right? So what exactly we can understand? We can understand we have a group of records which are similar in natures, right? In this case, if you see that they are similar in nature, but at the same time they are not similar, it means they are dissimilar with the other clusters, right? Let's understand the concept of clustering with the help of one small case study here. So with this case study, I have taken the 9 customers which is distributed across 3 different clusters, and we have a few features which describe these customers. The first one is it is going to be a number of items they are going to purchase, and the second one is what is the price they are going to pay for each. So what we did, we have made 3 different clusters. In cluster 1, we have a customer who have purchased very few high price items. Customer in cluster 2 purchase many high price items. Customers in cluster 3 purchase a few low price items. It means you can see that I've shown in the 3 different colors here. So these are the sample data sets we have taken, and which are similar in some sense. Like if you look at the cluster 1, a customer has purchased a few high price items. Customers in cluster 2 have purchased many high price items, and customers in cluster 3 have priced low price items. So based on these features, we have clustered them into a different groups or different clusters. Now this is a type of cluster example by which one can understand what exactly the clustering is. So where exactly one can use this, right? There are many applications for this, starting from we have a pattern recognition, we have a World Wide Web, where you must have seen that there are applications like whenever you go to the Google News, for example, you can see that there are many clusters which has been framed inside those Google News. So you have a news related to the sports, you have a news related to the particular regions, you have a current news, and etc. Right? Now, how exactly this can be done in the computers? Right? So how the computers or your machine is going to use these data sets and form the different clusters. For example, initial data set, you can see that we have a 4, 5, 6, 7, 8, 9 different data sets in the figure A. If you look at, these are the 3 different clusters, and based on that we have given a 3 cluster of data here. So based on the some kind of similarity, what similarity? If you look at this, if you look at one of the most common similarity measure what we use in today's clustering technique is the distance, right? So they are very near to each other, so we have formed different clusters here. And because we have framed 3 clusters here, that means that is an input given by the user. So he wanted to build 3 different clusters. So that's the reason we have a 3 different. For example, if the same user says that no, I don't want 3 clusters, I want 4 clusters. Now the same initial data set has been grouped into 4 different clusters of data. That is what we have shown in the figure C here, right? Now, what exactly the cluster analysis is? So as we say that cluster is a collection of data objects or collection of data records or items, and they are similar in one another within the same cluster. Please remember this. They are very much similar in each other. At the same time, they are dissimilar to the other objects with other clusters, right? So for example, if I'm talking about the figure B here, 3 clusters of data here. So we have framed the 3 different clusters here. So cluster 1, 2 and 3. So cluster 1, they are similar in each other, right? Based on the distance, they are very close, they are very near to each other, right? But at the same time, they are dissimilar to the other clusters because they are very far from them. That's the reason they are similar to one another within the same clusters. So what the cluster analysis does? So what it does, it groups the set of data objects into a clusters, right? And in previous session we have been talking about there are 2 different types of learning based on supervised techniques or unsupervised techniques, and we saw that in case of classification it's a supervised based learning. That means there is a predefined classes are there, but when it comes to clustering techniques, there is no predefined classes are there in your data sets, right? So this is a unsupervised based learning. So what exactly we need? We need an input for a system to your cluster analysis, right? And some kind of measures, measures of similarity or dissimilarity between these 2 samples. And once you know that based on what kind of measures you are going to take, then you are going to get the output from this cluster analysis. And output is always going to be the number of clusters. So number of clusters has to be defined by the user, the one who is actually interested in forming these clusters, right? So what is the 2 inputs user has to give? The input 1 is the number of clusters he has to define, and based on the number of clusters, what exactly he is going to get is final output is always going to get the number of clusters, right? So input is the data sets and output is your number of clusters you are going to form based on some kind of similarity measures you are going to take. Now let's look at the different applications of clustering. So I was talking about we have a pattern recognition system, we have an image processing system. People have been used to like these clustering techniques to form some kind of clusters, like for example you have seen the galaxy, right? So you know that we have a Saptarisis. So we know that there are 7 different stars which form one kind of clusters, right? So that is also one kind of cluster. So based on some similarity, because we know that whenever we see from Earth, and we see that they are going to form one kind of clusters here, because based on the distance and based on the how exactly they are going to behave, right? And based on that, we are going to form the cluster here. Similarly, we have a spatial data analysis. We have a thematic maps in the GIS. GIS is a geographical information system, and based on the clustering feature space, we actually go for the detecting spatial cluster, and which actually help them in spatial data mining. So data mining, if you look at the data mining process, we have defined earlier, it's a process of finding a patterns in your databases, right, or in your data sets. So once we know that your data set is there, so what exactly you are looking for? You are actually looking for some kind of pattern or some kind of knowledge from those data sets here. Similarly, we can do it a lot of applications we have in this market research, economic science. We have a World Wide Web where you can actually go for the document-based classification. You have a cluster weblog data to discover a group of similar access patterns. So web data, if you really look at the web data, so you have a website where the different clients or different users are actually visiting those websites. So whenever we visit a particular website, it's been logged, it's been recorded into a server. So all those data set can be reviewed, can be used to find some kind of patterns within those weblog data, right? You can actually form some kind of clusters. You can use some other data mining techniques, and this is one of the most widely used applications of clustering techniques. Similarly, if you talk about the specific examples of clustering applications, so we have in marketing where we can help the marketers to discover distinct groups in the customer bases, and they can use those patterns and they can use this knowledge to develop some targeted marketing programs. For example, if one wants to launch a new product, right, and within a particular region, he will look for different customers' profile based on what is their eating habit, what is their income, right, and based on that he can actually launch a new product. So that is a one kind of things which can help in increasing your market space. People have been using clustering applications in the land use, identification of areas of similar land used in the earth observation databases. People have used in insurance system where sometimes people go for the false claim, right? So sometimes people in insurance companies are looking for those people who is likely to do some kind of fraud. So clustering is one of the widely used application where you can actually find those outliers, or you can find those noise, or you can use these clustering techniques to find these kind of patterns. People have used clustering techniques in city-based planning, identifying group of houses according to their house types, values, geographical location. We have used in earthquake studies. We have observed the earthquake epicenters should be clustered along with the continent faults. So there are many applications, right? Now, if you look at the very specific examples which I'm going to discuss now, I have been using this particular tools known as WECA, which is stand for Waikato Environment for Knowledge Analysis. So this is basically a tool which is helping in doing some kind of machine learning or some kind of data analysis, which is a free open source tool which is licensed under GNU General Public License here. So when we install this WECA toolkit, it comes with a different data sets. So one of such data set is iris.arif. So iris.arff if you try to open in the Weka Explorer help you to look into what exactly what is there in that particular data set. So R for arif is one type of data set. So when you look at the iris, so iris is basically a some kind of flower which is found in the New Zealand here, right? And if you look at the Weka data set here, and this iris data set has a 150 records, and out of these records we have a iris setosa 50 records, iris versicolor as another 50, and then iris virginica as another 50 here. So basically this data set comes with a predefined classes. So we know that the first attribute or first row is basically iris setosa, first to 50, then 51 to 100, and then 101 to 150 to the iris virginica here. As I've said, like all these data set comes with a predefined classes, right? What are the classes here? We have a iris setosa, versicolor, and virginica. These are the predefined classes. But when I have defined the clustering, I said it doesn't come with a predefined classes. So what exactly we will do? We will try to delete these class attributes, right? And then we will see whether we can we recover these classes by clustering the data set or not. So there are many techniques. There are techniques like a simple, one of the very simplest or oldest way of using clustering technique is a k-mean techniques, where k is the number of cluster, and we do a lot of mean and taking the recursive way of doing all those data set, and then we'll try to find out whether the particular data set belongs to which cluster or not. Because in this case we already know that there are 3 different clusters, so can we recover these data sets? So answer is yes. So we will see that based on what suitable clustering techniques you are going to use, right? How many number of clusters, because in this case we know that there are 3 different clusters. So yes, so number of clusters, you will say that it is 3. So whenever you get the output from your this process, so ultimately what you get is the number of clusters, and you see that there are data set which actually belongs to iris setosa, versicolors, and virginica, right? So this is how exactly we have been used, and in the subsequent classes I will be talking especially on those important techniques I'm referring just now. So we have a partition based techniques, which is actually a k-means technique. We have a k-medioid technique. We have one of the most popular widely used clustering technique, that is a DB scan, that is what we call density based clustering here, and that is what exactly we will be using. So now let's understand what exactly a good clustering means. So just now what exactly we discussed, we started with simply defining what exactly the cluster is, which is a set of similar items, right? And these similar item is based on some kind of similarities, right? And one of the such similarity is in machine learning and in the data science or in data mining, what we use is the distance based similarities. So a good clustering method will produce high quality clusters with these 2 very, very important parameters. One is high intra-class similarity, and the second one is low inter-class similarity. So when I say high intra-class, so intra-class is within. That means I have formed the clusters. Inside that clusters, how closely they are related. And when I say, that means they should be very, very high. They should be very, very close to each other, right? And when I say low inter-class similarity, that means between. Inter is basically meaning the between. That means between the different clusters, it should have a low inter-class similarity. That means they should be very, very far here. So the quality of cluster is depends on both the similarity measure, what kind of similarity measure we are using. One of the most popular distance based technique is the Euclidean techniques, right? And how exactly we are using, right? And how exactly we are going to implement those things. And quality of clustering is also measured by its ability to discover some of or all of the hidden patterns here. As I mentioned in the very beginning, all the aim of all these data mining functionalities, whether you talk about association rule mining, whether you talk about classification techniques, or you talk about clustering technique, their job is to find or discover the hidden patterns from your data set. The data set could be a small data set, or it could be a very large data set, right? So all these techniques, including clustering techniques, will have some kind of ways to discover these hidden patterns from your data set. Now let's understand the same thing with the help of these diagrams here. I have shown the interclass distances are maximized. So when I say interclass distances, that means I'm talking about the different clusters here, right? And when I say intra-class distances are minimized, that means within the clusters. So you can see that I've shown in the red clusters here. I've shown the one arrow mark bidirectional arrow here. You can see that they are very close to each other. Another bidirectional symbol I have shown with the orange color. That means I am looking for cluster distances. That means they should be very far. They should be maximized, right? So given a set of data point, each having a set of attributes, right? So whenever we talk about data set consists of different features. It consists of different set of attributes and similarity measures among them, and based on those things our job is to find the clusters such that data point in one clusters are more similar to one another, and at the same time data point in separate clusters. When I say separate cluster, you can see that we have three different clusters here, three different colors you can see here. One is red colors, one is in blue colors, and one is in orange color here, right? So data point in separate clusters are less similar to one another, right? And as I mentioned earlier, we have a different similarity measures, and Euclidean distance is used if the attributes are continuous. But one of the major drawback with all those things is it assumes that your data set is a numeric data set, right? It assumes that they are continuous data set here, right? So if your data point or data set is categorical data, so your job is to convert those data set into continuous data set or numeric data set, and then use the one of the measures, Euclidean distance or any other data set you may use this, right? And based on this, what exactly we can do is we can form the clusters, and we can actually use the clustering techniques and find the different applications of doing all those things here. So if I want to summarize today's session, what exactly we discuss what is a clustering is. So we understand the clustering is set of similar items. It's a group basically. Cluster is basically a grouping. So in grouping you have a set of similar items, right? And when I say clustering analysis, so I said it's one of the unsupervised techniques which does not have a predefined classes, right? And we saw different applications, general applications of clustering, starting from pattern recognition to World Wide Web. And then we try to understand the same thing with the help of one example. I have shown you a brief about the Weka toolkit. I said Weka toolkit is one of the data set where people can explore or find a lot of hidden data set here, right? They can extract or they can use to discover the patterns from the data set. So Weka has a different functionalities starting from using association functions, or you have a classification techniques, you have a clustering techniques, many more regression techniques. You also have some features based on which you can extract the different features, right? So all those things were discussed, and we tried to understand if we delete the one of the predefined classes which was given in the Irish data set, right? Can we find their uh, uh, clusters? Can we build a cluster? And the answer is yes, right? So based on what techniques you are using, what appropriate technique you are using, based on those techniques, especially if we have a numeric data set, the one of the most commonly used and one of the oldest clustering technique is the k-mean techniques, and I will be talking about those clustering techniques in the next session. And especially I will be talking about the categorization of major clustering methods, starting from partition based techniques, we have a grid based techniques, we have a density based techniques, we have a model based clustering methods. And then we'll talk about, especially I will be talking about the algorithms, and we'll understand how the k-means works, right? So today's session, though I'm talking about the uh, very generic way of defining the clustering, but in the next session I will define how the clustering can be used, how the user can define the cluster. That is, when I say k means, so how the k is going to be defined, whether it is going to be 2 or whether it is going to be 3 or 4 or 5, right? So we'll try to understand if we change the number of clusters, whether there is any impact on the data sets or not, right? And based on that, we'll try to understand how the DB scan further can be used. And if you have any other questions, you can always contact us in our mail IDs, and you can always contact us through the our contact numbers here, and we are ready to help you and all. Right? With this, thank you.